This lesson is for Advanced Algebra, Lesson 10.8 on the Law of Cosines. The Law of Cosines is used for finding missing side lengths and missing angles in non-right triangles. Keep in mind that the only two times you'll use the Law of Cosines is for SAS setups and for SSS setups. So let's review what those are from geometry. If a triangle has SAS, that means side angle side, like the triangle that's pictured here. The two sides that are given and the angle between them is given. So if that is what you're seeing on the initial review of the triangle that you're given, then you should use the law of cosines to solve. If the triangle has all three sides given, side, 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 then you're also going to use the law of cosines. If it's not an SAS setup or an SSS setup, then you should go back and use the law of sines, the one from the previous lesson. So only in these two instances will you use this one for non-right triangles. For everything else, you're going to use the law of sines. So the law of cosines itself is given to you here. It's c squared equals a squared plus b squared, which so far looks like the Pythagorean theorem, with the additional element of minus 2ab cosine big C. Remember that capital letters refer to angle measures, and since this is a capital C and this is a lowercase c, there's a relationship between those two items. Those two things are across from each other. Big C is the angle, little c is the side across from it. So it's very important for students to pay attention to where the angle is and where the side is that's across from it. A and B are also given here as lowercase letters, so those are also side lengths. A and B are interchangeable, so if you goof up and put the B value first and the A value second, it'll still work. So we're going to start with SAS setups. If the triangle given has two sides and the angle between them given, you'll be using the law of cosines to find a missing side length. So what you're going to do is start labeling what you're given. If they give you an angle in SAS, which they should, because that's what that stands for, call the angle that's given big C and the side across from it little c. Then your A and your B are your other two sides, and those are interchangeable in terms of how you label them. I'm going to label this side A and this side B. If you had labeled them oppositely of me, you'll still get the same answer. So now we just substitute in the numbers. Resist the urge right now to try to calculate. Right now we're just in substitution mode. So you're just going to replace the numbers that you know, and then we'll calculate later. So I'm plugging in the A value, then the B value, and since we're doing 2AB here, you either need to use the dot for times or you need to put the number in parentheses. I'm going to use the dot, but the parentheses work just as well. And then cosine of the angle, I usually put the angle measure very large just so that it helps reinforce that the capital letters are the angle measures. Now you're just going to go ahead and grab your calculator and you're going to type in everything you just wrote in one big long line. The only change that will be made on your calculator is typically most calculators will put in a set of parentheses here around your angle measure, so just make sure that you also include the closing of that parenthesis. When you're all done, you're going to get an answer of 1228.15 approximately. The decimal does continue, by the way. And to complete the process, you need to find what C is. So to get the square to go away, you will simply square root. Now I want you to be careful on your calculator. You will not type in the square root of this number. I want you to use the second and then the square to get the square root, and then use the second symbol again and then use the negative sign, which should be nearby your decimal key. And what your calculator will actually say is ANS. What that means is it grabs the previous number, including all of the decimal places, and it uses that whole number for you. That entire number gets grabbed rather than just the rounded off number. And when you do the square root of the number, if you round it to the whole number, you'll get about 35. And so I'd like you to try now, or actually we're going to do together another example. So take a moment to copy this triangle. I want to clarify as you're copying that BC represents a side length. So if they're asking you to find this, they mean find the measure between sides B and C. Now right away we may have a problem here because they've already labeled with A's, B's, and C's. And normally we want the angle that's given in an SAS setup like this one is. We want this to be angle C, and they've already labeled it angle A. So just know that you can relabel as needed. So I'm just going to relabel in a different color here that this is going to be sides or angle C, and side little c is going to be across from it. And then I am going to be true here that the little b, we'll make that little b so that it matches with big B, but then this is going to now be little a. So now we're going to plug in the numbers again. So we've got c squared that we don't know, a squared is 9, b squared is 16. And so go ahead and give that a try in your calculator, pause the video. And so when you calculate here, you should get a number around 286.99 with extra decimals. Go ahead and do the next step, pause the video. So you'll take the square root of both sides, and then rounding that answer off to the nearest whole number, you should get about 17. So that's for SAS setups. You'll use the law of cosines. If you feel that you need some individual practice, I've got another example here for you to try on your own. Go ahead and give it a try, copy it down, find the distance between T and A. Go ahead and pause the video and I'll reveal the answer shortly. So here's your results. I went ahead and substituted the number in. When I calculated, I got about 13.99. After your square root, you get about 37.4. So your answer might be 37 depending upon what they ask you to round to. This next item is not something that you need to copy down. It's just something that I want you to watch and listen and kind of participate with here on the video. This is supposed to be an easy question for high school students to manage. Keep in mind that usually when you're looking at a problem like this, you're asked to solve for x. And so one of the common mistakes that you probably made when you first saw a problem like this, way back when, probably in what, 6th or 7th grade, one of the common mistakes may have been thinking that you could subtract 4 minus 3 here. It looks like it says 4 minus 3, so it would seem logical that you could do 4 minus 3 and get a 1x here, and now you're done. But we know now from having years and years of being in math class that with the rules of algebra, we would not be able to subtract those or combine them in any way because one has a variable with it and one doesn't. And so we would consider those being not like terms, and you can't combine things that aren't like terms. You can only subtract here if this had an x next to it. Since it doesn't, they're almost like apples and oranges and you can't put those together. So normally when we're looking at a problem like this, we try to solve by isolating the x. So we would move the thing that's furthest away first, which would be the 4. So we would subtract here, but we're not going to subtract it from the 3, we're actually going to take it away from both sides. So I think most students would go, yeah, I already know how to do this. What does this have to do with anything? Just trust me that going through this simple process will help you be more successful on the next one that we're going to do. So then when we get rid of the 4's here, the 3x drops down. And at this point, this is when students yell at me and go, wait a minute, you forgot to bring down the negative. That is a common mistake. Please make sure that you don't do that on the problem that we're going to be doing in just a moment. The next step here to get the x isolated is to, yes, you're right, divide by 3. We divide here because we want the 3's to cancel. But again, another mistake that I just made is you have to divide by the same number that's already there in order for that to turn into a 1. So we do need to divide here by a -3 on both sides. I want you to keep those steps in mind here, that we don't subtract these two because they're not like terms. We add the opposite to both sides, and then we divide, and when we divide, we need to be careful that we divide by the number with the correct sign in front of it. So keep those steps in mind when we do the next piece. The other type of problem we're going to do today is a law of cosines problem when all 3 sides are given. When all 3 sides are given, your job is to find the measure of a missing angle. So you can see here this is an SSS setup, and it's unclear right now which angle they want us to find. Keep in mind that in particular when I draw my triangles, I literally sketch them. So don't go by how the triangle looks, go by the values that are given. Now another piece of information we need to talk about, not necessarily related to this specific example, but to any geometric example that you're working with. If they ask you to find the measure of the smallest angle, you need to be able to identify which angle that is. According to the rules of geometry, the smallest angle is going to be across from the shortest side. So let's go ahead and write that down. And that's true not just for this triangle, but for any triangle. The shortest side and the smallest angle are always across from each other. That's also true of the largest angle. The largest angle is across from the longest side. So if they ask you to find one of those two, hopefully you can identify it now in your picture. So the shortest side here is side 8, so the angle across from that we're going to label big C. So then little c has to be the shortest side. Then your A and your B are interchangeable, so I'm just going to label those A and B accordingly. Now we're going to go ahead and substitute our numbers into the law of cosines. Hopefully by now you're getting comfortable with the law of cosines and how it's been stated. It's c squared, which in this case is 8, equals a squared plus b squared. Hopefully that looks familiar, that's just the Pythagorean theorem, minus 2 times a times b times cosine of the angle. And this time the angle's missing. We're going to go ahead and start to solve for the missing piece, which in this case is the c. We will do some calculating here of 8 squared. We'll do 12 squared and 10 squared, and we'll combine those because those are both plain numbers. 12 squared is 144, 10 squared is 100, 144 plus another 100 is 244. So I can combine those because they are like terms. Over here I'm going to multiply 2 times 12, which is 24, times 10, which is 240. And then the cosine c is still sitting there. I can't do much with that because I'm trying to solve for that. Now this is the point where I want you to think back to the really easy problem that we just completed. Right now we're sitting and we're staring at a problem just like this. The only difference is ours has a cosine with the x. Should we subtract the 4 minus 3? We decided we should not because they're not like terms. On this problem, same thing. These cannot be combined because the 240 has a cosine c next to it. So even though it feels like we should very easily be able to say 4 cosine c, don't do it. Because 244 minus 240 cosine c is not 4 cosine c. We're in a position here where we need to solve for c, so we're going to move the 244 to the other side. So we're going to subtract, but we're not going to subtract it from here. Make sure to be careful here when you subtract. I do have students who go backwards here. Make sure you do the top number minus the bottom number. And when you do that, you get negative 180. Don't forget here that the 240 drops down, but the negative drops with it, and then we still have cosine c that we're trying to solve for. Now we're at the point where we were right here. We have a number in front of a variable, so we're going to divide by that number on both sides. So we're going to divide by 240, making sure to do what? You're right, bring the negative with. So now over here, make sure you do the top number divided by the bottom number. And when you do that, you get 0.75. Over here, the 240s have canceled, leaving us cosine c. It's all right that you have some space here because hopefully you know on the next step we need to do a what? Yes, we need to do an inverse cosine on both sides. That's the only way to get the cosine to go away. The cosine is going to go away on this side because the inverse and cosine cancel each other out. And then over here we're going to round that off. And if we round to the whole number there, you get about 41. Remember that it is an angle measure, so make sure you put in the number with the degrees. So now I'd like you to try this on your own. This time, take a brand new triangle with new values, and I want you to find the measure of the largest angle this time. So take a good look at the triangle, mark it up as you need to, pause the video, give it a try, and the answer will be displayed shortly. So it's important here that you had marked that this was the angle you're supposed to find because it's across from the longest side. So the 15 squared has to be on the outside here, and your 11 and your 13 here are interchangeable. So if you had the 11 listed first and the 13 listed second, that is still considered correct. Now when you simplify, you've got the 225, the 13 squared and the 11 squared combined to make 290. The 2, 13, and 11 make a 286. Be careful here, what are you not going to do? You're not going to subtract these two and get a 4 there. If you got a 4, you got tricked. You're doing 4 minus 3x, and you know that should not be a 1. So we're going to subtract negative, or take away 290 from both sides. Then we're going to divide by the negative 286. Be careful here, you're not going to type in just 0.227. You want to use that second and then the negative command to get the calculator to grab the previous answer, which is a much longer decimal. If you round it off to the 10th, it'll be 76.9. If you round to the whole number, you'll get about 77. And again, make sure you put the degree symbol in. If you tried this problem and you still don't understand how to do it even after the explanation, make sure you talk to your teacher during class to get further explanation and further help. The next thing that I'd like you to try is something that I call spot the error. So you can go ahead and pause the video here and go ahead and look at each question. There's 4 separate questions here, and I've attempted to start each of them, but I've made an error or 2 or 3 on all of them. So what I'd like you to do is take a moment and find or fix the error on all 4 questions, and then go ahead and solve each of these for additional practice. So go ahead and give that a try, pause the video. And so you can see here that there was supposed to be a minus sign there. When you calculate, you end up getting 17. All kinds of problems on number 2 here. The 11 is in the wrong location, as well as the 13. 13 and the 11 need to switch places. Be careful there when you solve. Again, you should not get a 4 there. You want to subtract the 394 and then divide by the 390. When you do the inverse cosine as your last step, you should get about 46. The error on the bottom one here on the left, just a careless mistake there. I didn't write 110, I just wrote 10. If you calculate there, it's just a simple square root to get the answer. And then this one's similar to the one that we had done earlier. The 15 was in the wrong location. Remember that the 15 is a side length, so the side length has to go here. It's only an angle measure that goes in the big C location. So when you calculate there, it's the same one as what we had done before.